All right, so welcome back. We are going to jump into 3.2, which gets into measures of variation. Now, other textbooks, they may call this measures of dispersion, but they're both talking about the same thing. They're just talking about how spread out is the data. So, along with knowing measures of center, which gives us an idea about the middle of a data set, we may also wish to know about how spread out the data is, or classify the measure of variation for a given data set. So these two examples here both have a mean of 100, but we can see that the one has an outlier, it's spread out more, there's some holes in it and stuff like that. Whereas this data set is really compacted. It's between 90 and 110. It's still centered around 100. So should we treat these two data sets the same because they have the same mean? And the answer is no. We can't treat them the same just because they have the same mean. So if one's spread out more than the other one, we have to treat them differently. So how do we measure those spreads on those different data sets? Well, one way to do it is to use the range. So the range of a data set of values is the difference between the maximum data value and the minimum data value. Pretty quick, right? So if we have an example, we got 7448, 4911, 9051, 6374, 4277. So what would the range be? Well, we got to have the highest and the lowest. Those are our highest and lowest, so all we're doing is subtracting 9051 minus 4277 equals, and I don't want to mess it up, so I'm going to use a calculator, minus 4277, 4774. And don't forget your units. So 4774, done. But what does that tell you? It really doesn't give you a lot of good information. You know, all these numbers were already in the thousands, and we have a multi-thousand spread from the highest to the lowest. It doesn't really tell me if it's compact or what. So mathematicians said, well, we need to do better. So they tinkered with it, and they came up with the next measure, which is the standard deviation of a sample. So the standard deviation of a set of sample values denoted by S, and it's a lowercase s, be careful, lowercase, is a measure of variation of values about the mean. In other words, it can be referred to as an average measure of the amount each of the values differs from the mean. So let's take a look at a number line. Now, if I just kind of did some squiggles representing, data. So there's my data. All right, so let's say the mean is right here. And I wanted to know what S was for this. What's our standard deviation? Well, you can kind of see that if I'm going from the mean out to this upper edge, the average distance away is right about here. So this distance would be my S. Now, the one thing that's special about standard deviation, it takes account both sides while it's making this calculation. So it's also looking at this side and saying, okay, well, this one might not go quite as far, but, I'm still going to say that the average distance away on this side is that same value of S. So again, it's just an average distance away from the middle. So if it's compacted, what do you think is going to happen to S? S is going to get smaller because it's going to pull it in towards the middle. If it's really spread out, then S is going to get really, really large and demonstrate that because it's spread out more. So if S is small, it's compacted. If S is large, it's spread out more. So that's what we're going to be seeing with these different examples. So how do we find it? It's a formula. Well, this first version of the formula is the standard formula. It's a very clunky formula to use in your calculator. So it's not recommended that you use it. So don't use this formula. It's a lot more layers to the process. As bad as this formula looks, it's actually much, much easier because we know what n is, and so n is a big part of it. But these two summations can be a little bit tricky, so I'm going to break those out for you. So the first one is the first sum, and the second one is the second one. Now, how you interpret these is important. So let's look at this first one. So we know that that symbol means we're adding stuff up, but what are we adding? We're adding up the data, remember x is the data, squared. So you want to think of it this way. You want to square first, then add. Square the data first, and then add those values up. That's what this one means. This one is a little different though. Look at the way it's written. The parentheses are around the sum. So now this one wants you to add first, then square it. So it's a very subtle difference. And it turns out that this one is going to be very, very easy to find if you're doing all those other calculations for measures of center. So we're going to see that in action in just a minute. So this one's a little bit trickier because there's no real simple way to do it. You got to just crunch it in your calculator, but we'll see it in action. So square first, then add first, then square. So be careful. So let's try this first one, and then we'll take a break. So we got find the mean, median, mid-range, range, standard deviation for each data set. Use the shortcut formula when finding the standard deviation. So, well, let's go right to bat. So n, remember, is just the number of values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 10 numbers. X bar, we know whatever it is, we're going to divide it by 10. Now, if I remember correctly, this was a previous problem, so I am almost positive it adds up to 533. But let me double check. Look at that, 533. So 533 is the sum, and if we divide it by 10, we get 53.3. All right, so there's that step. Remember what X with the little squiggle means, right? That's the median. So we've got to first put these in order. Ugh. I'll just be careful. Okay, so now they're in order. Remember, we want the two middle ones. So 51 and 60 or 53. So if we add those together and divide by 2, 104 divided by 2, which is 52. Done. Mid-range. So remember, mid-range is the highest and the lowest divided by 2. So the middle of the range. So 34 and 79 looks like 113 divided by 2, which is 56.5. So 56.5. Now, the range is brand new. Remember, the range is just the highest minus the lowest. So 79 minus 34, which looks like 45. Okay, so those calculations should go fairly quick. Now the standard deviation part. So we need these two sums. So remember, this one is the trickier one. So all you're doing is you're squaring first. So we're going to take each of those numbers and square it and then add it up. So 34 squared plus 36 squared and so on. So, gotta use your calculator. 34, but what's nice is that sometimes your calculator has that nice little squared button. So if you square it, there it's already done. Plus 36 squared plus 39 squared plus 43 squared plus 51 squared plus 53 and 62, 63, 73, and 79. So it looks like 30,615. Now, this one I said is easier, but why? Well, remember, in the parentheses, it wants you to add up x, which means you just want you to add up your data. Where did you do that already? We already added it up when we found the mean. So as long as you're writing that fraction out, you have that data and you don't have to redo it. So I would always advocate you write this fraction out when you're doing your mean. So all we got to do is take 533 and raise it to the second power. So 533 squared is that 284,089. All right. Now comes the formula part. So we got to put all this information in there. So remember, your formula looks like this. Oops. Now, I don't expect you to remember it. I've been doing this a while, so I have it committed to memory. But let's just be careful how we put all our pieces in. So remember, n is 10. So we got 10 times, now this first sum is right here, this number, 30,615, minus, we already squared it, so we don't have to do anything fancy, just write this last number down. All over 10 times 10 minus 1. Now be careful, don't try to extend this parenthesis all the way down to the end. That's not a good practice. It's just around that first number and that's it. This number just kind of sits there and waits until this calculation is done first. So if we multiply 10 times that, and then 10 times, well, that's just 9. 10 times 9 is 90. So I'm going to squeeze down underneath here. So if we do that calculation next, so we got 306, oops, I forgot the 0 at the end, 306,150 minus 284,089 is 21,061. So we got the square root of 22,061 divided by 90. So let's divide that by 90. So we get the square root of 245.122 forever. And then we want to square root it. So right there, square root 15.656. Now rounding. Same rules as before. Carry one minimum of one extra decimal place than your data. So we need at least one. I probably will go 2 just because I like 2. So 15.66. All right, so let's stop there, take a breath, get a drink, and then we'll come back and we'll do the next couple of examples. See you soon.